So today, what are we working on? We are going to be doing U-substitution. What is the whole point of U-substitution? Why do we got to do it? Just because? No. We are doing U-substitution because this is going to help us do more advanced antiderivatives. Does that make sense to everyone? Okay, so here we go, guys. Let's go ahead and get started. I think I'm recording. Yeah, I am. Okay, let's go. And I think we're good. So it says, what's the difference between indefinite integrals and a definite integral? So let's talk about these two really quick. And it's not a hard question, guys. So an indefinite integral does not have limits. So if I write something like this is an indefinite integral because it's not defined. And if I write something like, oh, am I using my hotspot? It's fine. Yeah, that's fine. It's fine. All right, and if I have something like this, a to b of f of x dx, this is a definite integral. And it's easy to know those names. One of them says definite, so it's like saying defined. It has a set value. And one of them is indefinite, so it's undefined. Or it's not necessarily, you don't say undefined, you just say you don't have limits in there. Remember when you're doing the antiderivative of this, it has a plus c. While the other one does not have a plus c because that one has an exact value. Like we know what constant that is. We can find it. Cool or not cool, guys? Cool. Miss Tiff? Guys, guess what? We're already at 50% capacity. We have half the class here. No, we don't have half the class here. But we got 2 peeps, which is better than 0. Anything else better than, like, it was 1 for a while. One time we were at 3. That was pretty good. But anyways, we're all back, so it's all good. All right. Everyone happy? Are you happy to be here? Yes. Oh, you can close the window, miss. Or don't close it, but you can lower it. Okay. All right. So the next question, guys, it says integral of x squared minus sine x dx. This is an indefinite integral. So we're just going to take antiderivative. That's all we're going to do, guys. Antiderivative of x squared is, yeah, so you write x cubed over 3. Oh, here comes the tricky one. Antiderivative of sine x. I don't know, Chav. I know the derivative. Well, the derivative of sine x would have been cosine. But when you're doing antiderivative, then this is going to have to be, what's negative times a negative? So this is going to have to be positive cosine x. Now, because it is an indefinite integral, I'm not done. If you just leave it like that, you're not going to get full credit. What do I got to do? Plus c. You must add plus c for some constant c. I used to have a professor that would always want this for some constant c. It's not a big deal to me. You show me plus c, we're good. And then how do you test yourself? You can check yourself before you wreck yourself. Okay. No, I didn't come up with that one. I didn't come up with it. Someone else did. Yeah. I stole it from, I've been hearing it for a long time. I don't know where I got it from, but I heard it from somewhere. So if you take the derivative of this, you better get this inside expression. And you do. 3x squared over 3, the 3's cancel out. Derivative of cosine is negative sine, there it is. And then derivative of a constant is 0, and there it is. You got it, guys. So we're done. That's it. So here are some properties. You already know these properties. We're showing them again, just in case. Maybe you've seen these, maybe you haven't, but there you go. You got them now. And later on, I'm going to give you a table that's even better than this one. That's going to give you more details and more integrals. Cool? All right. Now, let's see what this whole fad is about U-substitution and U's and blah, blah, blah. And hopefully this starts making sense, guys, here. So it says, pay attention to the differential. So all that means is, what am I? Oh, okay. Sorry.
Sorry to interrupt. Could
Oh,
you
your
let
goodness.
Carolyn in? She said she's in the waiting room.
Oh, she is?
Yeah.
Oh, man. She's been there for a while. I'm sorry, Ms. Lanford. Are you in? All right. Hey, Ms. Lanford. Sorry, Miss. You missed all this stuff here, but don't worry. I'm going to upload the video, and this stuff here is just the difference between indefinite, integral, and definite. So you haven't really missed anything. You're about to get to the really fun stuff. So good thing you came in right on time. Thank you, Villacana, for letting me know. Thank you, Sister Villacana. Villacana. Oh, that's so funny. Who's that? Went, right? Okay. Sorry. All right, guys. I'm trying to think of other teachers that I can make an impression of, but I don't know if I can do a good one or not. All right, here we go. So I'm taking the antiderivative with respect to x. They tell me that u equals x squared and that f of x equals that. And I'm just taking the antiderivative and I want it to be in terms of x. So letter A is nothing. It's nothing. It's not a big deal. Letter A is just what we've always been doing. F of x is this function. So I'm just going to write x cubed plus 1 dx. You don't have to put parentheses there. But I like to put it because I know that each rectangle from the Riemann sums is width times height. And then the x cubed plus 1 is like your height and the dx is like your width. But you don't have to. You don't have to put the parentheses. You can just leave it. It's understood. And then we just do antiderivative. Antiderivative of x cubed is plus, and then antiderivative of 1 is just, and then I put plus c, because there's no limits on my integral. How do we feel, guys? Do we feel okay? All right, next one. Next one says f of u du. Well, I just come up here. It doesn't matter what I call it. I could have called it f of happy face, and I would have written happy face cubed plus 1. So if they call it f of u du, then that means I need to have the function in terms of u. And I'm integrating with respect to u. So I'm going to rewrite integral. And I'm just going to write u to the third power plus 1 du. And then I just take an antiderivative, guys. Antiderivative is u to the fourth over 4 plus u plus c. No, we're about to. Now, we haven't answered the question completely, guys, because look what it says here. It wants all of them in terms of x. So we're not done. I need to rewrite this in terms of x. So to help you out, because a lot of kids get confused here, this is u to the fourth. So put parentheses on that u there, because that's where we're substituting. So to help you out, just in case you guys get confused. Now, what does u equal? So anytime I see a u, I'm going to insert what in there? An x squared. X squared to the fourth over 4 plus, and then you can just drop the parentheses, drop it like it's hot. Oh, yeah. Okay, I'll stop. That was stupid. But so there it is. And then I'm just going to drop the parentheses. You know who does a really good, oh, yeah? Villacana. Villacana does a really good one. 4 times 2 is 8. So this is just going to be x to the 8th over 4 plus x squared plus c. So as you can see, you got to know a little bit of algebra, guys. If your algebra is not very good, you're going to have a hard time. Really, that's, as you guys have seen, I hope that you guys have noticed, calculus, like the calculus class itself, the topic, the calculus topic itself, calculus is actually easy, but it's the algebra and the pre-cal that is hard. So if your algebra and pre-cal has issues, then calculus is going to be hard. But calculus itself, don't tell people that it's hard, guys. So don't tell like, oh my God, calculus is hard. Like, no, calculus is easy. It's the algebra and pre-cal in the calculus that is hard. Okay, let's look at this one here. This one says, I'm integrating with respect to what letter? X. But it says f of u. So here on the side, I'm going to write, well, f of u is u, was it u cubed plus 1? Yeah. F of u is u cubed plus 1. I cannot, look, u cubed plus 1 dx. I cannot do antiderivative because these letters must match for you to do antiderivative. They don't match right now. So I am forced to do this U-substitution here. It says u equals x squared. I come back. I don't want to get confused. I'm going to put parentheses around the u anywhere I see it. And I'm just going to write what u is. What u is. Okay. So u squared, x squared, man, what the heck? X squared to the third power plus 1. So, and I guess I should have written f of x squared here, not f of u. There we go. So f of x squared is equal to x to the 6th power plus 1. This is what I'm going to write for my integral. I'm going to do integral x to the 6 plus 1 dx. I'm going to do my antiderivative. Antiderivative of x to the 6 is x to the 7th over 7 plus 1. And then make sure to put a plus. Oh, yes, plus x. There's an x there. It's not falling. There was an x there from the beginning. No, I'm kidding this. Thank you for hooking me up. And there it is, guys. Yeah, you're right. Let me fix the x there. There it is. Cool or not cool? Okay, so maybe you're still not impressed. You're like, okay, I'm not very impressed with this U-sub. This is nothing fancy. All right, here we go. We're getting to fancy ones. You do not have to use U-substitution if you can see it, guys. So, and it's okay. It's okay. What do you mean, Chavez, see it? Of course I can see it. Look, I'm looking at it. That's not what I meant. I meant if you can visually see the antiderivative, because some of you are really good at working backwards. Like, oh, what do I take the derivative that'll give me the sine x e cosine x? And you might be able to figure it out. In your head, subconsciously, you might say, oh, okay, the derivative of sine is cosine, and I'm already seeing chain rule there. So it must be maybe e to the cosine x, and then try it out, and you're like, oh, this is just missing a negative, and you put a negative. If you can visually see that, that's fine. That comes from experience. The more you do this, the better you'll train your brain to be able to see that. If you don't see it, it's okay, guys. It's okay. You just need more practice. You can always use U-sub. So how do you use U-sub? You got to notice a pattern. I see a sine x. I see a cosine x. I know they are related. So don't write anything down. Just listen so we can take this all in. So here we go. Don't write anything down, guys. Just listen. So what I'm going to do, I know cosine and sine x are related. I'm going to write u equals cosine x. Don't write anything down. I'm going to give you time. So don't write anything down, guys. I want you guys to just focus here. So if I know that u is cosine x, I'm going to take the derivative of this expression with respect to x. So I'm going to write du over dx equals, and the derivative of cosine x is negative sine x. Yes or no? Okay, don't worry, guys. Just listen. So now what I want to do, I'm trying to substitute stuff here because I want to integrate this, but I want to make it look easier. So I'm going to multiply this du dx. I'm going to treat it like a fraction, and I'm going to multiply by dx times dx. So I'm going to say that du equals negative sine x dx. This is what's called a differential. But for now, we're going to leave it alone. Are we still okay? All right. I can rewrite this expression. Look, all of this is a product. Sine x times e to the cosine x times dx. So I'm going to do a side note. And maybe I should have done the side note earlier first. A times b times c. Don't worry about that, guys. And those are supposed to be decimals. A times decimals. Those are supposed to be dots, like multiplying. A times b times c is the same thing as c times b times a, which is the same thing as b times c times a. I'm not going in any order. What I'm trying to say is it doesn't matter how you set the product. If it's multiplying, you can rewrite it however you want. Does that make sense? So look at this. I'm going to rewrite this, and I'm going to write it like this. E to the cosine x, and I'm going to write it, I'm going to put this in parentheses because I'm going to have to enter something. So there it is. Well, okay, you know what? Let me go slow. Is that the same thing as what I have in the top? You always want to have the dx in the back. There's nothing you can do about that dx. Leave it in the back, guys, because that's how you end the integral. So here's what you ask yourself. I have a negative sine x dx, and I almost have a negative sine x dx. Almost. I don't have a negative sine x dx. I put this in parentheses, and I like to do this. Delta math doesn't do this, by the way. I'll tell you the difference between delta and myself. I see a negative sine x dx, and I want to, okay, I'll make it negative. But when I do that, I got to balance it. If I put a negative right there, I got to balance it by putting a negative on the outside, and now everything is right in the world. Does that make sense, guys? Okay, let me tell you why I like, don't worry, I'm going to give you guys time to write. Let me tell you why I like doing it this way. Delta math does not do that. Delta math solves for dx by itself and then replaces dx with whatever it gets. I like this method better because I grew up with chemistry. I took chemistry my junior year, and in chemistry, I would always balance equations. And this method reminds me of chemistry because I'm just playing balance. I'm just balancing. That's all I'm doing. So I prefer to always balance. If you want to solve for an expression and then just replace that expression all the time like that, the way delta does it, you can go ahead and do it that way. I just feel like that doesn't feel natural to me. I like to do the balancing part. Does that make sense? Okay, don't write it down yet. Don't worry, we're about to. I can now substitute whatever I want to substitute. Negative on the outside, leave that alone. Look what u is. U is cosine x. I'm going to write e to the u. And this negative sine x dx, all of that is just du. And look at that. I now have an integral that is so much easier. Doesn't that integral look a lot easier? And now I just do antiderivative. Antiderivative of that, negative stays there. Antiderivative of e to the u is e to the u. Put a plus c. And then I can now write equals, and I can say, okay, well, let's write it in terms of x. Well, that's the same thing as negative e to the cosine x plus c. So there it is. That's my answer for that guy. Okay, now you can write, guys. Did all that make sense? I got a brand new Starbucks right here, and then another Starbucks. I can put you there, like I can move that stuff. Okay. Because I feel like you're way over there.
I don't feel like that.
Oh. Yeah, no, if you see it, don't do it. But
But like for that one, I would do it. Like the next one, I would do it now.
Yeah.
I don't know.
Okay. All right. Are we done with this, guys? Can we continue? All right. So let's see if we got the hang of it now. So I'm doing U-sub. The first thing you got to notice, you got to look for patterns. I'm looking at 5 plus 2x cubed, and I see x squared. And immediately I start thinking, every time I take a derivative, the polynomial goes down by 1 degree, doesn't it? Well, look, that one says 2 and that one says 3. So you're going to make the u the one with the higher degree. So I'm going to say u equals 5 plus 2x cubed. And I'm going to go right into writing my differential immediately. If you want to keep writing du dx, because you're taking the derivative of u with respect to x, go ahead. But it's common practice to just write it out immediately. So Chavez, what do you mean? This is what I mean. I'm going to write du is equal to 2 times 3, 6x squared, and then I just put the dx immediately. If you don't like that, if you're like, oh, I don't like that, then go ahead and write 2 statements. Du dx equals 6x squared, du equals 6x squared dx. Oh, the reason we don't care about the square root is because in a little bit when I substitute u, I'm going to have u just with a square root on it. And it's going to be a lot easier. All right, so here we go. I'm getting ready to substitute. I see an x squared, and here's my x squared dx, double underline. Well, let me make that single underline there. So there's my x squared dx. It's missing a what? So I'm going to force a 6 in there. Now that's magic. If I do that, I need to make things better in the world. How do I do that? Put a 1/6 on the outside. There it is. It's balanced. Yeah, because I got to balance it. 1/6 times 6 is 1. Does that make sense, Tiff, or no? Okay. When I say balance, guys, you want to make sure the product is equal to 1. So whatever number you put in there, just take the reciprocal of it. Are we good? Okay, so now we're good, guys. So here we go. 1/6. The 6x squared dx is du, but do not write it first. Write it at the end because that signifies the end of your integral. Integral, square root of u, du. Doesn't that look a lot easier? Okay, the most common mistake, and I'm just pointing this out because someone's going to make it. The most common mistake is I see this. That is not the same, guys. This, you're telling me to integrate 1 du, and whatever that is multiplied by square root of u. That is not the same. Do I make myself clear there, guys? Sorry, I'm not trying to. That's why I tried to think of like, what else can I say different than that? Make sure the du is always at the end because that signifies like quote unquote the end. The start, the end. So the du always has to go on the end, guys. And remember, all of this goes back to areas under the curve, FTOC, width times height, width times height, width times height. What's this whole U-sub about? Just making it easier to integrate. That's all it's about. Is that easier to integrate? Yes. Rewrite it. 1/6 integral u to the half du And here we go. 1/6 antiderivative of u to the half. That is going to be u to the 3/2 divided by 3/2. So I'm going to write 2/3. So put a little dot there. 2/3. Yes, I guess so. I won't confuse anyone. If I had limits, it would be that. Oh, well, plus c, right? So I'm going to write plus c. And let's go ahead and figure out what this constant is now, or what this is. I'm going to multiply. So let's see. 2 goes into 6 3 times. 3 times 3 is 9. You didn't have to do it right there. You could have done it at the end. 1 over 9. And u is 5 plus 2x cubed. So I'm going to write parenthesis. 5 plus 2x cubed, close it, to the 3/2 plus c. Come on, guys, let me get this before class. Did all that make sense?
No.
Oh, okay. What did I lose, you miss?
How did I don't understand what you did when you got square root of u.
Oh, the expression 5 plus 2x cubed is u. See?
Oh, and then where did the x squared go?
Oh, you see the x, okay, I'm going to rewrite this. Maybe I should have done that first. So look, this right here rewritten, I'm just talking about the integral there, is integral square root 5 plus 2x cubed, that's on there, and then I can write 6x squared dx. So now it's easier to see. So notice the 6x squared dx, that's just du. See? And then the 5 plus 2x cubed, that is u. I mean, that's not u as in Nadia Gonzalez u. That is u as in 5 plus 2x cubed. So integral square root of u, and that's all du, so du. Does that make sense, Gonzalez, or no?
I think so.
No, tell me, what's going on?
Okay, so you got u because
Uh-huh.
you like du is the derivative of u.
It's called a differential because technically it's like saying delta u. What I did is this. Yes, you're right. Well, okay, the derivative of u with respect to x. So look, du dx equals 6x squared. But I didn't want to write that because it's common to just go right into it. So treat du dx like a fraction, and I could just multiply this side by dx times dx times dx, and then the dx's cancel out, and then you just have du equals 6x squared dx.
Oh, okay, and then
from there, I just looked at my integral symbol and I saw what I could substitute stuff with. So 6x squared dx is the same thing as du, so I did that. The square root of 5 plus 2x cubed, the 5 plus 2x cubed is a u, so I did that.
okay.
What do you think? Should we do more problems?
Yeah.
Okay, we'll do more problems. What's up?
I have a question. So
Yeah.
whenever you multiply at the end by 1/6
Uh-huh.
times 2/3 u to the 3/2,
Uh-huh.
so you're not multiplying 1/6 in a polynomial, right? You're just like adding it.
Well, I'm multiplying. It's like saying this. Watch. See?
Oh, so she's asking what you do like to the plus b. Yeah.
Oh, the c is a constant. So technically, it's 1/6 times a constant, but anything times a constant is still a constant. That's what I.
If we were to find c, we would have to multiply by 1/6.
No, we would use an initial value that they give us to find c. Don't worry, we're gonna get to that because later on there's gonna come a time where we're adding constants. But why? What? Okay, it's like saying this: constant 1 plus constant 2 is equal to another constant. So you're not gonna say c1 plus c2 equals c3. You're just gonna say they're all constants. So some
But
constant.
I just kind of thought it as like we do 1/6 and then 1/6 times in parentheses 2/3 u to the 3/2 plus c. So then that means we have understood the 1/6.
Correct. If c were a variable, yes, but c just means constant. So, okay, that's actually a really good question. So let me address the class. So the question was, guys, How come I'm not putting, how come I'm not doing this and then going, and then how come I'm not saying it's 1/6 of that constant like that? So the reason why you don't do that is a constant times any number is still a constant. Like it's still a constant. It doesn't matter what it is. So to make life easier for you, so you don't have fractions all over the place, you just say plus C. And you don't do anything with the C, you just leave it alone. Because a constant times anything is still going to be a constant. Does that make sense to you guys? Okay, good question, Tiff. Yeah, because I said that C is a constant, but I'll tell them anyways, because just in case. Good job, miss. Remember that if there was a variable besides C, because C is not a variable, C is a constant. If there was a variable, you would multiply the 1/6 times everything. So if there was a U there, you would multiply it times the U, or whatever variable you have. Cool, guys? Any other questions? Are we good?
Yeah, I have a question.
Oh, ask, please.
How do you know what your U is?
If it's a situation like this one, the U is going to be the one with the higher power. You got to recognize relationships between one polynomial and the other. Does that make sense? Like we recognize I had a degree 3 and I recognize that that was a degree 2. Well, when you take a derivative of something cubic, you're going to get something square. So that's how we recognize what is U and what is like what. That's how you're going to recognize what U is. No, okay, I know it sounds very funny, but good. Are we cool, Dina?
Yeah.
Don't worry, we're going to do a whole bunch of problems, guys. A whole bunch. So look at this one. At first glance, you're like, I don't know what to do on this one. It just says cotangent 7x. Is there a rule? And maybe there's a rule. I don't know. Let's see. I don't see it. But I'm sure there is. I'm sure there's a table somewhere for it. So here's what I would do. I'm going to rewrite this in terms of cosine and sine. Integral. Cosine 7x over sine 7x. dx. And now on the side, all right, Dina, you're going to help me out. And it's okay if we get it wrong. What do I make U? And as a matter of fact, I actually kind of want us to get it wrong so we can see. So don't write anything down right now. So what do you want to make U? Do you want to make U cosine 7x or do you want to make U sine 7x? Those are the only two choices we got.
I don't know.
Yeah, just give me one. It doesn't matter which one. I actually kind of want to get it wrong first. Which one?
Cosine.
Cosine. All right. So don't write this down, guys. Just listen. So if I make U equal to cosine 7x, then du would be a negative sine 7x times 7 dx. I just did it in one step. If you want to do it in 2 steps, go ahead. Are we okay so far with that statement there, guys? Now look at this. It's going to be pretty hard for me to get this to look like sine 7x dx. As a matter of fact, it's going to be impossible. You're not going to be able to get this fraction to be negative 7 sine 7x dx in the numerator. You're not, because the sine 7x is in the bottom. Do you guys see that? So this is not the right idea. Well, it's the right idea, but this is not the right U-substitution. So let's try the other one. So now you can write. So look, this is, because it is the correct one. U has to be sine 7x. Why? Because du is going to be equal to 7 cosine 7x dx. If you don't like doing it in 1 step, do it in 2 steps. It's not a big deal. Now look at this, guys. You're saying, but Chavez, I don't have a 7 cosine 7x dx, but I do have a cosine 7x dx. So now I'm going to do some quote unquote magic. I'm going to do some balancing. I prefer it this way. Delta math does not do it this way. Delta math solves for dx and then does all that good stuff, which is fine. It's perfectly fine. I'm not judging them. I prefer the chemistry route. I also think the chemistry route is faster, by the way. So here it is, chemistry route, balance. I add a 7. If I add a 7, what do I put on the outside? 1/7. There it is. Everything is right in the world. It's perfect. It's balanced. So I'm going to write 1/7 integral That's 7 cosine 7x dx. That's just du. Look, it says there. It says du. Du over, and then the sine 7x is just u, and there it is. That looks a lot easier to integrate. You probably don't recognize it, but I'll write it for you so you can see it. This is the same thing as saying this. 1/7 integral 1 over u du. So now hopefully it's easier to, hopefully now you see it. What is the antiderivative of that? Yeah. 1/7 ln. And by the way, when there's no limits, you're supposed to put absolute value for ln because the domain is all real numbers except 0. So ln of u, put absolute value on that, plus c. I don't want it in terms of u though. I want it in terms of what? X. So my real answer is 1/7 ln, absolute value, and u is what? So that's what I'm going to type in there. Sine 7x, close it, plus c. And yes, you can make a case about 1/7 being multiplied by the c, but remember what we said, 1/7 times the constant is still a constant. How do we feel, guys? Okay. Hopefully we're doing awesome. Oh, no.
No, I was looking at the next one.
Oh, all right. Find the indefinite integrals. In each case, you can use trig identities to set up substitution. Here we go. Pre-cal. Oh, darn pre-cal. You can see, guys, calculus is not hard. It's the pre-cal and algebra that is hard. You see it and you're like, I don't know. What is that? Another ln? Rewrite it, guys. What is 1 over cosine squared? Uh-oh. Yeah, I think I heard someone say it. Did you say secant? Good job, miss. Secant squared 2x. Maybe you don't need u sub. Maybe you do. If you see it, go ahead and do it without u sub. Some of you guys are already there where you can do it without u sub. If you don't see it, use u sub. U is going to equal 2x if you were to do u sub. Oh, because the derivative of what is secant squared? Okay, let me slow. Oh, how did I find u? I made that expression there, the 2x, the u, because I see that on the outside is I don't have any variables. So derivative of a linear line is just a number. So it's like a 1. That makes sense? So I just said, plus the 2x is the only variable I have in there. So that means that wherever the variable's at, if it's just by itself, that's going to be your u. If it's like one of these. So u is going to be 2x. If you want to use u sub, maybe you already see what the antiderivative is. And du is going to be 2dx. I don't have a 2dx. I'm going to force it though. I'm going to put a 2 in there. If I put a 2 in there, I put a 1 on the outside. 1/2. Here we go. 1/2 integral secant squared of u du. Hopefully you know, I hope, the antiderivative of secant squared is what? Oh man. Starts with the letter T. Second letter A.
Tangent.
Yeah, tangent, guys. Tangent of u, and then I'll put a plus c on it. And I don't want to write it in terms of the letter u. I want to write it in terms of x. So the integral of dx over cosine squared 2x is nothing more than 1/2 tan 2x, because that's what u is, plus c. How are we feeling so far? All right, letter B. Oh no, Chavez, I don't know. That x, by the way, I know that I should have used parentheses. That x is with the cosine. Cosine is never by itself. I know I made it look like it's x dx. No, that x is with the cosine, guys. All right, with this one, Let's see. You can't make u x because then du is dx, and you're going to get the same situation, cosine cubed u du. So let's see. We can't make u cosine cubed because then there's no sine if I take the derivative, but I can get a sine. So side note, here comes pre-cal. Valentine's formula. Cosine squared x plus sine squared x equals 1. So make sure one of these days for Valentine's, or maybe just to be like cool, you write your friend or your significant other a nice little card, and you tell them cosine squared plus sine squared equals 1, that you're cosine squared, they're sine squared, and together you guys are 1. And if he or she doesn't get it, dump them immediately. Upgrade. Find yourself a new boy or a new girl, because yeah, they're not about it. Okay, I'm kidding, guys. I'm kidding. Go ahead and educate them. No, well, okay. Let's get back to calculus. All right. So I see that this has cosine and sine embedded in there. And do you guys agree that cosine squared x times cosine x is equal to cosine cube x? Do you guys agree with that statement? Perfect. Yeah, you guys agree because you guys took algebra and pre-cal. So because I see that, I can rewrite this as cosine squared x, cosine x dx. And now that I have that cosine squared, look what I can do. Cosine squared is equal to 1 minus sine squared. And I think this is a really cool trick. Now that I have that, I can rewrite that cosine squared. Here we go, integral symbol, parenthesis, 1 minus sine squared x, close it, cosine x dx. Now I'm good. You're good. By the way, all this is a product, right? If you want to write parentheses here like that, go ahead. I wouldn't. I would leave it alone right there. Here we go. I'm going to make you sine x. Chavez, why? Why are you making u sine x? Do you see what's going to happen next? No? I'm going to make u sine x, guys, because look what happens. Du equals cosine x dx. Oh my God, look how beautiful that is. If it's so perfect, like so perfect, look at this. What is cosine x dx? Du. Integral, parenthesis, 1, and what was u? Sine x. 1 minus u squared, because, okay, just in case, side note, sine squared x means sine x with a square on the outside like that. So I hope that we know that, guys. So that's continuing your side note. Well, all right. Du, perfect. Look, guys, perfect integral. It even has the parentheses and times du like perfectly the way we want it. Antiderivative of 1 is, we're doing respect, well, it would have been x, but I'm doing it with respect to what letter? So we're going to write u minus, what's antiderivative of u squared? Perfect. U cubed over 3 plus c. Now, I don't want it in terms of u, I want it in terms of x, so I usually like to rewrite it, and I like integral of cosine cube of x dx is equal to, and now I'm going to write it in terms of x. U was sine x, so I'm going to write sine x minus sine cube x over 3 plus c. And I know what some of you guys are thinking. Chavez, I can just type this into Wolfram Alpha. Do you guys use Wolfram Alpha? I can just type this into Wolfram Alpha and it'll give me the answer. And you're right, it will. But the AP exam, you're not going to be able to use Wolfram Alpha. There's my answer, guys. You never heard of Wolfram Alpha? I have a subscription to them. They're so... Okay, next time I will. All right, guys. Do you think we can still handle some more or no? Okay. Yeah, there's only a few more. All right. And I was going to split this up into 2 days, but I didn't think there was enough content for 2 days. We're going to do more advanced ones tomorrow, so don't get me wrong. But I didn't want to split this up into a 2-day lesson, 2 days lesson. So here it is. Notice that now all of these integrals from now on, they have limits. Do you guys notice that? Okay, here's what we're gonna do. The whole, you got me confused there, miss. The whole point of U-substitution is to make life easier. If it has limits, you're not gonna change it back to X. You're gonna leave it in terms of your new stuff. Does that make sense? Let me tell you again. All of these, we've been going back to the original, back to X. Don't ever go back to your X, but in this case, you go back to the X because it does not have limits. Does that make sense, guys? But on this one, it has limits. There's limits. So once we change it, we're never going back. Once you change, you don't go back. Once you get a new partner, you don't go back to your old partner, guys. Leave them alone, or her, or whatever. Okay. Sorry, guys, if we're talking real talk today. All right, here we go. I see this, and I'm like, I don't know how to integrate that. I know that secant x tan x, the antiderivative of that is secant x. I know that much, but that's not secant x tan x. That's secant squared. See, there's a square there. So how are tan and secant related? That's what you got to ask yourself. Do you make u equals tan? What's the derivative of tan? Oh, perfect. There it is. It actually would have worked both ways too, by the way. I think it would have worked both ways, but perfect. I think yours is better though. So u is equal to tan. So du, the derivative of tan, we said that it was secant squared x dx, and look at that, secant squared x dx. So here we go. I put a new integral. Do not put limits, and I'm going to write u du. Don't put limits yet. These limits here were the limits when you were talking about integrating with respect to what letter? X. But now you're integrating with respect to u, so you need new limits. And it's really simple to get. Relax, guys. We have an expression here. So all we do is direct substitution. Plug in the 0 in here to get my new limit for u. What is tan of 0? So you got to know a little bit of pre-cal. Tan of 0 is 0. So that one stays the same. Now I'm going to plug in the power over 3 into that x. Chavez, I don't know what that is. Power over 3, remember guys, is up here. That was 1/2 square root of 3 over 2. So tan of power over 3 is square root of 3 over 2 divided by 1/2. So it's just going to be square root of 3. I put square root of 3 up there. So you got to know some pre-cal. If we don't know pre-cal, you're not going to be able to do this question. All right, there it is. There is no reason to go back to your x. No, there really is no reason to go back to your x, but there's no reason to go back to the expression x here. You're going to leave it in terms of u. So here we go. Antiderivative of u squared over 2, and I'm evaluating this from 0 to square root of 3. Fundamental theorem of calculus, upper minus lower. So let's see, square root of 3 squared. Did I do that right? Square root of 3 squared. No, let me put the square up here. Square root of 3 squared over 2 minus 0 squared over 2. So there it is, guys. Square root of 3 squared is 3. So this is just going to be 3 over 2. Done. That was a lot easier, wasn't it? Let's continue. All right, Deanon. Don't worry. No pressure, Deanon. I'm looking at this problem. What do you think you should be? I mean, you're going to be an engineer or a doctor, but what do you think you should be on this one?
X squared minus 4.
That's right. Why is u going to be x squared minus 4?
Because that highest power.
Yeah, because well, don't be a robot. You told me highest power, Chavez. I'm just going to choose u to be the highest power all the time. Because when I take the derivative of x squared, it's 2x, and I have an x in there that I can use. Does that make sense, guys? So I'm going to say u equals x squared minus 4. Or did you just get it, Godina's? du equals 2x dx. I like to do the balancing. I like to do the chemistry, guys, the chemistry route. If you do it my way, it's going to help you a lot when you take chemistry at the university and you're balancing oxygens and you know, sodiums and all that good stuff, chlorides, chlorines. I like to do the chemistry route. 2x dx, I put a 2, I put a half. Chavez, I've never done one of these with limits and a half and everything. That's why we're doing this one. 1/2 integral. The 2x dx is du. The x squared minus 4 is u. I need new limits. Plug in the 0 in here. 0 squared minus 4, -4. That's why the antiderivative of this one's going to have an absolute value. You'll see it right now. Plug in the 1. Not into the u there, into the x. 1 squared is 1. 1 minus 4 is -3. I'm going to rewrite it so you guys can see it easier. 1/2 integral -4, -3, 1 over u du. And if you think that you're going to have a hard time, do this. So you can see that that half is going to be on the outside and you can distribute it later on. Or you can, well, in this case, this one's pretty straightforward. It's just one term, so you can multiply it immediately. But if you feel like your algebra is going to have issues, you can do that. Here we go. There's no reason to go back to the x's. You're just going to leave it in terms of u. Antiderivative of this is, what's antiderivative of 1 over u? ln, absolute value. ln, absolute value of u. Close it. Put a -4 on the bottom. Put a -3 on the top. It is okay to multiply the 1/2 immediately. You only have one term. It's all about algebra. Here's where people might mess up if you had multiple terms. It's all about algebra, guys. Both terms are going to have a half on it. If you want to include it, go ahead. If you don't, that's fine. Here's my 1/2. I'm going to work on the bracket stuff alone first. ln, absolute value of -3, close, minus ln, absolute value -4, close, equals 1/2, bracket, ln of 3 minus ln of 4. No, you don't have to do all these steps. Some of you guys are probably like, man, Chavez, I did this answer real quick. I'm just trying to show as much detail as I can for everyone. 1/2 ln of 3 over 4. And there's even another answer if you really wanted another one. Yeah, square root. And there it is, guys. Okay, how many more do we got from delta? Got it. Okay. So some of you guys are going to see the delta mass route. If you want to go that route, like I said, go ahead. It doesn't feel natural to me. It feels kind of, I'm not going to say robotic because we're always solving for variables and we're always solving for stuff in math, right? Like, oh, get x by itself, get y by itself. Delta math gets dx by itself and replaces dx with whatever they got. I'm okay with it. You can do that. But I prefer my way. All right, here we go. They tell me this. All right, guys. I want to make sure that you guys are not confused. Just because there's a u in there and this equals 3 doesn't mean that if I do this, don't write this down, just listen. If I call it all of a sudden w, what is that? It is still 3. It doesn't matter what it is, guys. As long as these match right here and these match, this will always be 3, no matter what, all the time. Remember that this letter is a dummy variable. It just so happens that we're doing u sub. So, you know, they put a u in there and, oh, let's see what's going on. Cool or not cool, guys? Okay, here we go. What must be the value of this? Okay, let's write that down. -6, 3, f of 3x dx. I don't know what that is, but I know what this one is. So I'm going to say on the side, I'm going to say u. I'm going to equal that to 3x. So I'm going to go du equals 3 dx. What am I missing for me to do that substitution? A 3. So I put a 3 there. If I put a 3 there, what do I put on the outside? 1/3. So, this one just had one variable, and the only variable I had was 3x, so it was automatically just that. You know what I mean? Okay. So now I'm going to write 1/3. So here we go. That 1/3 stays there. Integral, I'm going to have new limits because I'm writing it in terms of a new letter. F of 3x is equal to what? U. And there's a 3dx du. So let me see what my new limits are. Plug in a -6 in here. 3 times -6, that's -18. And then plug in the 3 in there again. 3 times 3, that's 9. Oh, look at delta. They're so funny. One-third times 3. 1. You just get a 1. Just a 1. And there it is, guys. One more. All right, Deanan, help me out here. I'm not picking on you, Deanan, I promise. I just want to make sure that we got it down cold. Now, don't tell me the higher power. Tell me something better than that. Which one's going to be U? And you're right. It is the one with the higher power. What's U, and tell me why?
9 minus 5x cubed.
Perfect. Why?
Because when you do the derivative, it becomes negative 15x to the... Oh, wait, no.
No, you're right. No, you're right. When you take the derivative, you're going to have negative 15x squared. And even though I don't have a 15x squared, I do have an x squared in there, and I can make it look like negative 15.
And
I like,
multiply 3x squared.
So here we go. Negative 15x squared dx. For those of you that don't see it, look at this. I can multiply that 3 by what to get, I need it to be a negative. So I can multiply that 3 by negative what? I'm going to rewrite it, guys. Yeah, perfect. I'm going to rewrite it, and whatever's in blue is what I'm going to multiply to edit it. So here we go in blue. I am multiplying by -5, so that way this expression here, tied with this, let me put an arrow here like that, will be negative 15x squared dx. Does everyone see that? And now if I put a -5 in the inside, on the outside of the integrand, I put a what? Oh.
1/5
Positive or negative?
negative.
Perfect. Perfecto. There it is. So everything in blue is stuff I added. It's just balancing. If you do it my way, you're gonna be a killer in chemistry when it comes to balancing equations. Tell your professor, give me a whole bunch of equations to balance, professor. I got this. And then when he asks you, like, how did you get so good at balancing all these redox equations and reactions? You're gonna tell him, oh, in calculus. In calculus, you did chemistry? Like, oh no, in calculus, I just did a lot of balancing with integrals. It's the same concept. And the professor's gonna be, he or she's gonna be like, wow, you must have had a good teacher. And then tell them, yeah, Chavez at YWLA. And then tell them to email me or her. No, I'm kidding. I'm not kidding, but I'm kidding. Okay, anyway, let's continue. -1/5 integral. Don't put limits, leave it alone. I guess let's rewrite it first so you guys can see it easier. Square root of u over 2. I never did anything with that 2. I should have taken it into account. That's fine, leave it alone. Du. I don't like that 2 there. Do you guys like that 2 in the bottom? Because I don't like it. Oh, you like it? Oh, they like it. Yeah, but I want to take it out. It's a constant. I'm going to use one of my properties. Relax, relax. You're not going to have to erase anything. I can already see some of y'all looking like, oh, I have to erase. Look, guys, I'm just going to do this property over here. I think I put it in here. Good thing I did it. Let's see. I'm just doing this. Look. I'm just doing that property. I'm just going to take it out. No, you don't have to erase. Perfect. So this is going to be negative 1/10 integral square root of u du. I still don't have limits in there. Let's see what my new limits are. When x is 0, u is 9. I know, guys. It sounds funny. When x is 1, 9 minus 5 is 4. You know what? I'm going to use another property. What property do you think I'm going to use? See if you can predict what I'm thinking. Yeah, why? Why Godinez? All right, so Godinez was able to predict what I'm thinking. Look at this. The top is a 4, the bottom is a 9. I don't like to count backwards, guys. I want to count normal, like normal people. So I'm going to switch those limits, and I'm going to turn that negative on the outside into a positive. 1/10 integral 4, 9 square root of u du. In a little bit, we're going to see if Desmos will give us that answer by hand, see if they match. It's going to match. 1/10 bracket antiderivative of u to the half, that's going to be u to the 3/2 divided by 3/2, so that's going to be 2/3. Put the bracket, close it, put a 4, put a 9. Since I only have one term, guys, I can actually factor that 2/3 out, because think about it. A times B times C is the same thing as C times B times A. I can just, that 1/10 and 2/3, I can just put them together. Does that make sense to you guys or no? It's just algebra. It's just algebra. 2 goes into 10 5 times. 5 times 3 is 15. And I'm just going to do upper minus lower. 9 to the 3/2 minus 4 to the 3/2. Chavez, I don't like your algebra. That's okay. You can do your algebra as long as it's correct. As long as it's correct math. 1 over 15. Chavez, I need a calculator. No, you don't. The square root of 9 is 3. 3 to the 3rd power is 27. Minus the square root of 4 is 2. 2 to the 3rd power is 8. 27 minus 8. Last time I checked, that was, I don't know, 27, 17, 18, 19, 19. So I get 19 over 15. We're going to verify this. You know what? Let's not use Desmos. Let's use our calculator. All right. Let's use our calculators just to verify, because that was the last one. So if you have a chance, take out your calculator, guys. I'm going to go to, where are you? All right, let me share my calculator. And I'm just going to type this guy in immediately the way it looks there. Math 9 from 0 to 1. Hopefully it doesn't have a hard time trying to calculate it. And I'm going to do the fraction feature. So the fraction feature is the alpha y equals enter. I'm going to type 3x squared square root of 9 minus 5x cubed over 2 dx. Let's see if the calculator has a hard time. It did not. Let's see if 1.266666667 is 19 over 15. I have a feeling it is. Look at that. Look at that. Isn't that beautiful, guys? I didn't get to this question. I was typing out the notes earlier, and I was trying to get to the last one, but I got it with you guys here now. That's beautiful. All right, let's all come back.